Welcome to this long-awaited installment of Modeler's Notebook about the track plan for Bethany Branch Line, a prototype freelance model railroad in N-scale. The prototype for my model is the Wellsburg-Bethany and Washington Railway of 1926, a trolley line that served the small college town of Bethany, West Virginia. To learn about the geography and history of the prototype, watch my previous episode of Modeler's Notebook on YouTube. Link in video description below. In this program, I'll explain the two layout levels, the train elevator between levels, subdivision of the track into power blocks, my design philosophy, the parade level track plan, the scenic level track plan, scenic illustration, and next steps in layout construction. My Bethany Branch Line layout has two levels, 19.1 inches apart. Each level fits into a space 140.5 inches wide by 84 inches deep. The reach from the aisle to the backdrop in most places is 24 inches. 4 columns support the upper train deck. They're small and won't obscure the view too much. Construction and wiring for each deck will be hidden behind smooth facia boards, painted black in the fashion of Grant Eastman's excellent N-scale layout, Southern Alberta Rail. Link in video description below. Light-emitting diode strips will illuminate both upper and lower levels, and valances will hide the light strips, as they do on the SAR. The lower level of the Bethany Branch Line, called the parade level, is where I'll assemble and store trains. It has a simple design, flat and level, with 5 continuous nested loops wrapped around the entire deck in a dog bone arrangement. The parade level won't have much scenery, maybe only track ballast and ground cover for parading my trains around the continuous loops. My previous Modeler's Notebook video tells the story of a prototype time, 1926, and place, the northern panhandle of West Virginia, that inspires my plan for the Bethany Branch Line model railroad in N-scale. The scenic level is where bits of that prototype time and place will be recreated. Here is the track plan for the scenic level. Later in this video, I'll give a detailed explanation of the track plan and zoom in on this illustration for a close-up view of the scenery and structures planned for the finished modeling. Space is at a premium in my small train room, so my train elevator is the perfect solution for transferring trains between levels. Link in video description below. The elevator needs very little lateral space, the width of only one viaduct track bed. The elevator track is just over 78 inches long, which is the maximum train length on the BBL. On either the parade or the scenic level, the elevator track completes a continuous loop of track around the layout. On the level not occupied by the elevator, track 1 is closed by automatic gates. To keep trains from falling into the elevator shaft, I designed and built an Arduino-based control system that operates the train gates and automatically switches track power. Link in video description below. If sensors detect a blockage at the gates, such as a train in the way, the system will enter error mode, shut down the elevator, and wait for an operator to clear the blockage. On the parade level, trains along the back wall of the train room can enter from either side onto the train elevator for the ride up to the scenic level. In similar fashion, when a scenic level train has completed its run, it can be piloted back onto the elevator from either direction for transfer down to the parade level. The elevator ride is fast, only 18.23 seconds to raise the elevator track 19 5/8 inches, and only 17 seconds to descend the same distance. This is probably much faster than a helix ride for the same elevation change. Storing and staging trains on the parade level will keep the scenic level tracks open and uncluttered for operations, as well as for continuous running. In summary, the train elevator will keep the Bethany Branch Line running smoothly and efficiently. Tracks on both levels will have isolated power districts called blocks. Bus wires feeding the blocks will be wrapped around induction coils that detect where trains are. This train detection data will be sent to JMRI software running on my iMac computer. JMRI is short for Java Model Railroad Interface. which is free open source software for programming and managing DCC model trains. Link in video description below. JMRI will use the block detection data to set signals and to program trains. Another advantage of dividing the layout into blocks is switching off to conserve power and to silence noisy locomotives. I'll use JMRI's virtual control panels for switching. The virtual control panels will be cheaper to make than hardware panels and are easily updated. Link in video description below. I decided against having open-ended stub or spur tracks in this track plan. I'd like to explain why. Like most modelers, I went through a lot of variations of my track plan before eventually settling on the current design. The early versions had stub sidings, but I eventually eliminated them because they restricted train flow too much for my liking. I'm not into switching puzzles, trailing and leading turnouts, and other operating conundrums. There's room for only 1 or 2 operators at a time, perhaps with a couple of onlookers, so I won't need to keep a large crew busy with train schedules or switch lists running on fast clocks. It's basically just me and my trains. Stub sidings evolved in the real world of trains because there's no choice. Either cost or geography dictates that they have only one connection with the main line, a dead end. Otherwise, sidings would be through tracks, which would make them runaround or passing tracks. Most track planners value runaround tracks for flexibility of operation. My entire parade level can be thought of as a marriage of 5 runaround tracks. My scenic level also has runaround tracks on the main line, with few stub sidings. There are only 8 stub tracks here, all for the locomotive yard. Most model railroads have stub sidings, which are considered prototypical. Link in video description below. I admit that my continuous loops are not prototypical, and I don't really care. I'm building a freelance layout with no pretensions to realism. My track plan includes numerous double crossover turnouts, also not prototypical. The crossovers enable any segment of running track to be used as a passing siding or runaround in either direction. I freely admit that I might change my mind later and decide that I want to have some stub sidings. I'll remain flexible enough to make changes as needed. As they say, I'll cross that bridge when I come to it. Now, let's break down the parade level track plan. The parade level is symmetrical. Trains emerge from the elevator in either direction onto track 1 and immediately go over a re-railer track and an uncoupler track, then curve around along the sidewall to the crossover ladder, where they can be routed to track 2, to track 3, or to track 4. Additional double crossovers access track 5. Track 1 is reserved mostly for assembling trains, for navigating to the other tracks, and for continuous run around the parade level when the elevator is present. Tracks 2, 3, and 4 are for train storage. Track 5 is reserved for assembling trains and for continuous run. Track 5 also has loops for reversing train direction. Train storage on the parade level naturally favors unit trains with dedicated locomotives, such as coal drags, passenger trains, and wave freights for mixed cargo, leaving switching operations such as rail car drop-offs and pickups to be done on the scenic level. However, partial rakes of cars also can be stored on the parade level as needed. Uncoupler tracks are distributed around the dog bone to help with sorting. The various colors of the parade level block diagram represent 39 separate track blocks. A total of 18 of the blocks on the interior tracks are available for train storage, more than enough for my small layout. All of the blocks are long enough to hold the longest train on the BBL. Trains maneuver easily to access the crossover ladders for navigation to any block. This parade level track plan has several advantages for assembling, storing, and parading model trains. The first advantage is bidirectional flexibility. Any train on the parade level can move as needed, no planning required. The symmetrical track plan allows trains to circulate clockwise or counterclockwise. The double crossover turnouts on both sides of the layout allow easy migration and parking in either direction. The second advantage of the parade level track plan is the reversing loops to orient trains as needed for transfer to the scenic level. Trains are reversed on a single crossover on either side of track 5. To prevent a short circuit that normally happens when a train reverses direction, I'll send track power to each reversing loop through a Digitrak's AR1 automatic reverse controller, which continuously monitors the track power polarity and instantly flips the polarity when a short is detected. Link in video description below. The third advantage of the parade level track plan is minimizing shunting back and forth to store trains. With the parade level's continuous loops, trains are simply pulled forward to the desired storage location and generally will not need to reverse direction to park or to launch. The fourth advantage of the parade level track plan is its ample space for mounting layout electronics, such as DCC command station and boosters, lighting and animation controllers, elevator control system, turnout encoders, LocoNet network, block detectors, power supplies, and the like. I don't want to hide away the electronics in cabinets or under deck. Instead, I want my electronics in full view for ease of use, troubleshooting, and maintenance. Next is the scenic level track plan. We'll tell the story of Bethany Branch Line's scenic level by following a Baltimore and Ohio Railroad passenger train that originates at Wheeling, West Virginia in the south, follows the BBL main line, stops at Beach Bottom, and continues on to Wellsburg. We'll disembark at Wellsburg Station and board the Bethany trolley for the 8-mile ride through the countryside to the village of Bethany. Just like the prototype, the main line follows the Ohio River, with stops at the river's key tributaries. In the south, Wheeling Creek forms a natural harbor for boats on the Ohio River, attracting heavy industry and the B&O's regional hub. Upriver at Beach Bottom, Windsor Coal Company's tipple fills coal barges destined for power plants and steel mills up and down the river. And further upriver, Buffalo Creek harbors the Wellsburg Brilliant Ferry, which carries passengers and vehicles hourly across the river to the neighboring state of Ohio. The Bethany trolley line follows Buffalo Creek through the mountains to the highland village of Bethany, from which the BBL gets its name. Our passenger train emerges onto the scenic level aboard the train elevator, which is along the back wall of the train room at the highest main line elevation of 4 inches. Any trains on the elevator will be clearly visible to operators. The painted scenic backdrop fully extends behind the elevator along the back wall and curves down both sides of the train room. Trains can depart the elevator in either direction. In this illustration, our train heads left on the main line track toward Wheeling Yard. The track is level at 4 inches to the bottom of the left dog bone loop, then descends 0.6% along the sweeping 15-inch radius curve to an elevation of 3 inches at Wheeling Yard. Wheeling Yard is level to prevent rail cars from rolling. The yard has 4 multi-purpose through tracks linked by double crossover turnouts. Trains headed for the steel mill take the mill loop connected to yard tracks 1 and 3. The mill loop climbs a steady grade of 1.1% to an elevation of 4 inches at the bottom of the dog bone loop. A long passing siding is available for operators to spot cars for the steel mill. They can run around parked rail cars by using the double crossover at the bottom of the loop. The large area inside the mill loop is reserved for the steel mill and loco yard. The mill loop is a simple but flexible design. Now let's take a look at the locomotive yard. Locos needing service take track 2 off Wheeling Yard onto the lead for the locomotive yard. The lead has a 1.4% grade down to the turntable's elevation of 2 inches. The loco yard sits in a bowl-shaped land formation that is lower than the surrounding mill tracks. The loco yard has a most unusual feature for a model railroad. There isn't room for a space-hogging roundhouse to store locos. Instead, all but one of the loco storage tracks extend into tunnels dug under the steel mill above. The stub-ended loco storage tracks are striped in this drawing to indicate tunnel tracks. To access the hidden loco tracks for maintenance, I plan to model the steel mill on a removable module. Having shown you Wheeling Yard, the steel mill, and the loco yard, it's now time for our passenger train to depart Wheeling Station and head out on the BBL main line toward the river town of Beach Bottom. The two-track main line doubles back on itself twice to make the trip seem longer and to make the descent more gradual. The grade is 1.35% down to Beach Bottom at 0 inches elevation, the lowest point on the BBL main line. The mainline loops are hidden inside tunnels, which makes their running time seem longer and obscures the unrealistically tight curves. Double crossover turnouts on the straightaway allow our passenger train to run around any trains parked at Beach Bottom Station. After taking on coal, water, and sand at the depot, we continue on the BBL main line toward Wellsburg. The main line to Wellsburg first hides in a tunnel, then emerges in reverse direction at another double crossover, where trains may switch tracks if needed to prepare for arrival at Wellsburg Station. The double-track main line then proceeds along another sweeping curve with outer radius of 15 inches and inner radius of 13 3/4 inches, arriving at Wellsburg Station at the bottom of the layout dogbone. The trip from Beach Bottom's elevation of 0 inches to Wellsburg's elevation of 2.5 inches is a steady 2.3% climb. This model emulates the prototype route from Beach Bottom to Wellsburg that climbs a high bluff overlooking the river. We debark from our imaginary passenger train at Wellsburg Station to catch the next trolley to Bethany. While waiting for the trolley's departure, there's time to trace the rest of the mainline route. Trains have two options at the next crossover. The left fork follows the Bethany Branch Line's magic loop back to Wheeling Yard, completing the circuit for continuous run from Wheeling to Wellsburg and back. The left fork to Wheeling Yard climbs a 0.4% grade. The right fork of the main line climbs a 1.3% grade up to the train elevator. When the train elevator is parked at the scenic level, another continuous run circuit is available around the entire scenic level of the layout. Now that we've traced the entire BBL main line, let's head back to Wellsburg, where the Bethany trolley is about to depart. The prototype trolley line snaked through mountainous terrain, crossed Buffalo Creek at 4 points, climbed the steep Buchanan's Hill, and crawled along a high trestle called the Narrows. I plan to model these features on the Bethany Branch Line. The trolley line is much steeper than the mainline railroad. Heading out of Wellsburg, the trolley climbs a 2.9% grade to the foot of Buchanan's Hill. The hill itself is a whopping 4% grade. One trolley car by itself should have no trouble climbing the hill. The trolley line descends at a 2.2% grade from the top of Buchanan's Hill to the village of Bethany. I plan to automate the Bethany trolley. I'll also prepare a reenactment of the time when brakes failed going down Buchanan's Hill and the trolley derailed. Like the parade level, the scenic level track plan offers several advantages for model railroading. The first advantage is bidirectional flexibility. Trains on the scenic level proceed from the elevator in either direction. We trace the counterclockwise main route from the elevator to Wheeling through Beach Bottom to Wellsburg and back to the elevator. But trains also can operate clockwise from the elevator to Wellsburg, through Beach Bottom to Wheeling and back to the elevator. The 8 double crossover turnouts interspersed along the main line allow trains to pass each other in either direction. This matches the parade level's number of crossovers. Bidirectional flexibility enhances point-to-point train operations as well as continuous running. The second advantage of the scenic level's track plan is reversing loops to orient trains as needed. The mill loop on the left and the magic loop on the right both function as return loops for whole trains. Individual locomotives can be reversed on the turntable. The turntable has twin leads to enable several locomotives to wait in queue. As on the parade level, Digitrak's AR1 automatic reverse controllers will monitor electrical polarity to prevent short circuits. The third advantage of the scenic level track plan is minimizing shunting back and forth to store trains. When shunting is needed, as in recovering a caboose after spotting freight cars, the crossovers at each station allow mainline tracks to be used as runarounds. The fourth advantage of the scenic level track plan is continuous running on 2 independent routes. The first continuous route follows the magic loop between Wellsburg and Wheeling and reverses direction on the mill loop to make a complete circuit. The second continuous route uses the elevator track to connect Wellsburg with Wheeling. This route does not have a reversing section. The two continuous routes use different tracks and do not interfere with each other. We've examined the scenic level track plan in detail. Now let's look at an illustration that brings the scenic level to life. This illustration shows what the scenic level might look like in its full glory. Let's examine it close up. The train elevator at the highest mainline track elevation. A freight train waiting for the elevator gate to open. Passenger train platforms at Wheeling. The B&O Railroad terminal on the platform. Main line tracks passing underneath. The city of Wheeling. 3 yard tracks emerging from tunnels under Wheeling. A coal train crossing Wheeling Creek. The steel mill with blast furnaces. Down below, the locomotive turntable. Loco storage tracks in tunnels under the mill plateau. Wheeling Wharf on the Ohio River. Double mainline tracks approaching Beach Bottom Station. The Windsor coal tipple filling barges on the Ohio River. Company houses for mill workers at Beach Bottom. Double main line crossing itself. The main line emerging from tunnels and climbing the bluff toward Wellsburg. The town of Wellsburg on the Ohio River. The Brilliant Ferry docked at Wellsburg Wharf at the mouth of Buffalo Creek. Wellsburg train station with main line and trolley platforms. The Bethany trolley line crossing Buffalo Creek. Waugh's grist mill on the Buffalo. The trolley line climbing Buchanan's Hill. Overlooking Windsor coal mine in Schoolhouse Hollow. Main line left fork for the magic loop back to Wheeling. Main line right fork back to the train elevator. The first trolley tunnel at the top of Buchanan's Hill. Crossing main line tracks to Wheeling. The Narrows trolley trestle. Overlooking LaBelle Farm. Entering the second trolley tunnel. Emerging at the village of Bethany. Bethany College's old main hall on the hill above. And our scenic tour of the Bethany Branch Line is complete. What's next for the parade level? With the train elevator installed and operational, it's time to complete the bench work, assemble wiring harnesses and electronics infrastructure, cut sections of rigid foam for the track base, trace the track plan onto the track base sections, install the train track on each section and wire it, mount the sections of track base on the bench work and interconnect the tracks, run trains to test the track work and fix any issues as needed. Use JMRI software to author a virtual control panel for throwing turnouts and controlling trains. And run trains. The Bethany Branch Line track plan tour is now complete. Now you know just about everything I know about planning my prototype freelance model railroad in N-scale. Producing this video helped me to refine my track plan and to prepare for the build. A good investment of my time and energy. For more information, check out links in the video description below. Stay tuned to this channel for more progress as construction continues on the Bethany Branch Line. As always, thanks for watching.